In this guided lecture, we are going to look specifically at some examples of parallel and perpendicular lines. Now, there are quite a few different ways that some of these equations or questions can be formed. One way is you could be asked to simply find a parallel line based on the given information. You could be asked to find the perpendicular line. You could be asked to find both, a parallel and a perpendicular. Or you could be asked to determine what the two given lines are, be that are they parallel, perpendicular, or neither. Well, in order to do that means you kind of have to have a little bit of knowledge behind the definitions of parallel and perpendicular. So when we're talking about parallel, we are talking about same slopes, but different y-intercept term, or b terms. Okay. Now, when we talk about parallel, we have an abbreviation or a symbol, so we use two lines that are right next to each other. That means parallel. And we also have an equation that we use to look at. In other words, we want to test, does M1 equal M2? Okay. Now, you must satisfy this equation in order to prove that you are parallel. Perpendicular is a little bit different. So when we're talking about perpendicular, its definition says that we have opposite reciprocals. Okay. So again, perpendicular also has a symbol. It looks just like a, say, perpendicular line. Okay, so you can see you've got your perpendicular angle here. So I like to call it the upside down T with the box. And when we're looking at this, there's a couple ways that we can do it. First, we can look at saying that M1 times your M2 should be -1. Okay? Or you could look at it as my first slope has to be -1 over my second slope. Now, if I'm looking at these two equations, the easiest thing to do usually is to use this first one where we are multiplying the two terms together and then solving to double check and see if it equals -1. But for some students, recognizing the opposite reciprocal idea is what is needed. So you just have to do what's best for you and the way that you like to see it. Now, in this particular problem, the directions say that you need to determine what's going on between these two lines. So the easiest way to do that is going to be to rewrite into y equals mx plus b, because then from there you can simply compare the m terms. Okay. So we're going to go ahead and do that. So I have 5 equals 11 times x minus y minus a 2y. Okay, so we've got 5 equals 11 times x minus y minus my 2y. So I'm going to go ahead and simplify this down. First, distribute the 11. So 5 equals 11x minus 11y minus a 2y. Combine my y's. 5 is equal to 11x minus 13y. I'm going to move my x over and divide by -13. So here I'm going to have -11x plus 5 equals -13y. Divide everything, and you get 11 over 13x minus 5 over 13 is equal to y. So here what we found is that my first slope, or the M1 value, is equal to 11 over 13. Now, before we jump to any conclusions, we have to simplify the second. So we have 13y is equal to -11x plus 3. Divide everything by 13 and we get that y is equal to negative 11 over 13x plus 3 over 13. This says that my m2 value is negative 11 over 13. So once we find our two slopes, we have to now test them. So the first thing that we need to test is we need to test, are they parallel? So we're looking at m1 equaling m2. And does that happen? Well, in our case, my first m1 is 11 over 13, and it does not equal negative 11 over 13, so they are not parallel. Okay, so here what this is this says that this is not parallel. The second thing that we have to look at is, are they perpendicular? So perpendicular, the easiest thing to do is to say, is m1 times m2 equal to negative 1? So let's look at that. m1 is going to be 11 over 13. I'm going to multiply that by negative 11 over 13. Well, that does not equal negative 1. Okay, if you look, 11 and 11 is 121, 13 and 13 is 169. That does not give you negative 1. So these would be considered to be not perpendicular. Since I've proven that they're neither parallel nor perpendicular, it means that these ones are considered neither, and this would be your answer. The other type of question you may see a lot with parallel and perpendicular says, given the following information, find the equation of the line that is parallel and perpendicular to the given, and leave it in slope-intercept form. So I'm giving you a line, and I'm giving you a point, and I want to know another line that is parallel, and then another line that is perpendicular. So the first thing that I would do is I would take this, and I would rewrite it into slope-intercept form. So you're going to have 2y is equal to negative 6x plus 1. So y is equal to negative 3x plus 1/2. What's important to note is that your slope, or your m value, is equal to, your m1 value is equal to a negative 3. So here is the important thing that we had to take out of this, okay, is that slope. Now the first thing that we're going to look for is we're going to go ahead and look for parallel. So we have that m1 has to equal my m2. Since my m1 is negative 3, it means my m2 is negative 3. And we also have to use the point negative 1, 2. Okay? So we're going to start with y minus y1 equals m times x minus x1. So we're here going to have y minus 2 is equal to, we're going to use the parallel slope, so the same slope, negative 3 times x plus 1. So here we're going to go ahead and solve it. So y minus 2 equals negative 3x minus 3. So we're going to add 2, so y equals negative 3x minus 1. So this right here is parallel. Now let's look at perpendicular. Perpendicular again says that if I take my first slope and I multiply it by the second slope, I should get negative 1. So we got to figure out what that second slope is. So we have that negative 3 times my second slope equals negative 1. So my slope here is going to be 1/3. Now notice the rule said opposite reciprocal. So opposite means opposite signs. My first slope was negative, so my perpendicular is positive. And then reciprocal says take the reciprocal of your number. So my first slope is the whole number, the reciprocal is flip it over. So now we're going to do the same thing. We're going to do y minus y1 equals m times x minus x1. So here we've again got y minus 2 equals, we're going to use the reciprocal slope, so 1/3 times x plus 1. So y minus 2 equals my 1/3 x plus 1/3. So y is equal to my 1/3 x plus my 1/3 plus 2. So y is equal to my 1/3 x. And then here, this 2 would turn itself into 6/3. So this becomes plus 7/3. And here is your perpendicular. So I've got my parallel line and my perpendicular line to the given information that we had in the beginning. So there's a little bit to guide you through some parallel and perpendicular practice. So if you have any questions, please feel free to let me know. If you feel like you need any additional examples, or you just simply want to work through a problem that's really been bothering you, please let me know that as well. Otherwise, I hope you enjoyed this lesson as much as I did, and I look forward to seeing you next time.